Okay, it's 6 o'clock, so we're going to go ahead and get started. We'll probably have some people join us as we continue. I really thank you for taking some time out of your evening to come in and talk to us and learn about the SKYWARN program, what we do with the National Weather Service, and how you can report information to us. You're really our eyes and ears where we can't be and where our technology doesn't reach, so we appreciate all the help that you're providing. We also encourage you to, like I said, visit this link, weather.gov/VEF/SKYWARN. There'll be more information, especially like the printable brochures. There'll be a booklet, a little bit more information on the program. So the more interest you have, you can definitely go there and check it out. If you have any issues, we will be available in the chat, so let us know. Also, if you have any questions as we go along, you can put them there and we can go ahead and address them at the end. So let's go ahead and get started. So, like I said, this is SKYWARN Weather Spotter Training. My name is Ashley Wolf. I am a meteorologist here at the National Weather Service in Las Vegas. So we're going to go ahead and move through the training. A little bit about what we'll be doing today, what we'll cover. We're going to look at who we are at the National Weather Service, what we do, why it's important that you're here, some of the weather definitions, some terminology. We are weather nerds, so some weather is important to talk about. Some of the thunderstorm types, severe weather, monsoon season, things that you would see here in the desert Southwest primarily. Hazards from any of those thunderstorms, dust storms, hail, and how to be safe if you do encounter any of those hazards. And then a review of some information on how to talk to us, and then maybe a final exam or not, just kidding. But as I said, as we go through, if you have questions, we'd love to answer them. We'll go ahead and address them at the end and have a question and answer session. So let's jump in. The big question is who is the National Weather Service? What is it that we do? So here's a video that was put together by Minneapolis that discusses that a little bit, hopefully. Or not. Oh, here we go. Oops. Try that one more time. So you can see from that video, I mean, we do a lot of stuff. There's a lot of different types of weather that we have to handle, and we also have to communicate. But what exactly does that all mean? How do we handle that? So first and foremost, one of our main things that we do at the National Weather Service is watches and warnings. We're the official source for any of the watches and warnings that you see, whether it's on TV or through an app, whether it's text message or emails. All of that is coming from your local National Weather Service office. And then we work with others in the community to help spread the word when it comes to hazardous weather. So we are the official source for any watches and warnings. We also do have our own forecasts. We have a wide variety of forecasts based on the user database. So we have ones for airports, for fires, out in wildfires, for boating, and for the public. We do provide public forecasts through about 7 days. We also maintain in climate weather. We want to make sure that the information that is getting out to people is accurate. So we do quality control all the information coming in. We also do education and outreach. We love talking to people about weather. So if you invite us out, there's a good chance that we will come out to your schools. We do big science festivals, safety festivals, that kind of information. And we want to be part of the community. It's about building a weather-ready nation. Unfortunately, we can only reach so many people, but when we get involved with communities, they can help spread that safety information as well. So yeah. Another big thing that we do is decision support services, and that's a really big thing that we do here in Las Vegas because we have a lot of people visiting this area, whether it's for hiking or in Las Vegas or down on the lakes or up in the mountains, all the way out to California, Death Valley. We have a wide variety of partners to work with different needs. And if you put people outside during events or festivals, and then you have winds or extreme heat or flooding coming through, that's a significant hazard that can be really dangerous really fast. So we work side by side with community leaders to ensure that they have the latest information and up-to-date weather information to make their decisions to keep you guys safe. We also do large on-site deployments. We'll embed ourselves with the community and the people making the decisions based on that weather so that they can better decide what to do. An example of that was just recently we sat with the people making the decisions at EDC here in Las Vegas because there was a significant amount of people outside and weather can creep up really quickly. So we do a lot in the communities. And finally, we do some science. We do research, we do presentations, we do papers. We do local weather models. We're interested in learning more because weather is always changing. The technology we're getting is always changing. So we do constantly do research and explore more how we can better provide the information. Altogether, though, this really comes down to we want to keep you safe. Our mission statement is to protect life and property and enhance national economy. So when we get to work together in these 4 categories, we are able to do that better and keep you guys safe. That's really what I want to do here, is to send the information so that you guys know what to do and how to understand it. So in case you don't know who the National Weather Service is, we do have 122 offices across the United States. And if you see here, we are here in Las Vegas. We have the 3rd largest forecast area. So each one of these offices, you see forecasts and issues warnings for that specific area. So ours is the 3rd largest. And, you know, taking a look inside, most offices are about the same. We have about 20 meteorologists alongside support staff, technicians, managers, to come together and really provide weather information. We do a lot of that through technology. We have specialized equipment and workstations so that we can manipulate the information and the weather data for each specific weather situation. I don't want to look at snow information in the middle of summer, well, hopefully, and I don't need to look at heat extremes when it's December. So depending on each situation, I will change things in the forecast and in the models for each specific information. A look at our office. We are located on the south side of Las Vegas, so we are local and in this community. This is an aerial shot. Here you can see on that side of the building, that's where we actually released the weather balloon, which we'll talk about in just a second. You can see the whole setup there. Behind us, we have mainly the rain gauge here. The biggest thing with that is that we are one of the official sites to report any rainfall that does fall here in Las Vegas. So we will go out and measure that rainfall manually. We do have weather instrumentation sited here so that we can get the latest weather data. We have satellite dishes, and that is sending in information from all over the country and even the world about the latest weather models, satellite data, radar data, so that we can bring it into those computers that I showed you before and take a good look at what we need to look at. We do a lot of communicating, so we have lots of communication towers and antennas so that we can reach all parts of our very large forecast area. But like I mentioned before, one of the big things that we do is the weather balloon. Out of those 122 offices that you saw, about half of them do a weather balloon. So here in Vegas, we do ours about twice a day. And what we do is that allows us to get weather information and observations in the vertical as you go up in the atmosphere. And as many of you know, weather doesn't just happen at the surface. Things changing in the atmosphere as you go up makes a big difference of what we're going to see here at the ground. So weather balloons are one of those ways that we can get that information. Basically, the setup is a big latex balloon that we blow up. We fill ours with helium. It's attached to a parachute so that when the balloon eventually pops, the weather instrumentation here at the end can float back down to the surface. And if you happen to find it, you can send it back to us and we can refurbish it and use it again. Here's a picture of what the actual instrumentation looks like. It's all inside that box and attached to the box. From that, we can get things like wind, temperature, height, and the amount of moisture or humidity in the atmosphere. All that really comes together so that we can take a look at everything and make certain decisions and goes into our weather models. We release those twice a day, every day. Here's a picture of our colleague Chelsea out in the rain, so it doesn't matter if it's raining or it's windy or if it's freezing cold or extremely hot. We're outside releasing this weather balloon, and you can see how big this balloon is compared to her because it needs to go up really far in the atmosphere. A good flight takes about an hour and a half. It gets about 100,000 feet up in the atmosphere, which for weather nerds is about 10 millibars is a good flight. So we'll get the whole troposphere, the tropopause, and hopefully part of the stratosphere. And then the box that she's holding there has all the instrumentation. It sends it back to us. And the cool thing about the weather balloon is that the offices that also do the weather balloon, we all release it at about the same time so that we get this really nice snapshot of how things are changing across the United States in the vertical. So some old school technology, we've been doing this for a very long time, that hasn't changed significantly, that we still rely on today. But one of the other things that we need are spotters. That's why we're talking to you and training you so that we can have accurate information. But what is a spotter exactly? So you see here in this picture, there is a difference between spotter and chaser. A lot of times when you say, hey, I need you to go look out at the weather, you think of storm chasers, which is okay. They get a lot closer than we particularly like people to get because they are well trained. They typically have a significant amount of equipment. They understand what they're doing. Here, we really don't recommend that for most people. It's perfectly fine to be a spotter exactly where you are, as you see in this first picture, where they're inside, they're safe, and they know just to call us. You're reporting when it's safe. I don't want you not to be safe. Running outside and taking a selfie with the winds or with the possible tornadoes isn't going to help me at all. It's just going to put you in danger. So no selfies with the weather that is unsafe, though we do enjoy weather pictures. One of the reasons we need spotters, though, is because I'm only as good as my technology and my computers. And if I don't know exactly what's going on, it's hard to estimate because my computers are estimating for me. So we need eyes and ears on the ground. We need somebody looking outside saying, yeah, this is actually happening, because there's a lot of things that can go wrong between cloud and ground that can screw up what I think I'm looking at. So by you guys reporting what you see, it fills in those gaps. It shows us where we might not even have data. We have a very large forecast area, but only so many instrumentation out in the field. And you can also tell us things about trends. You can tell us whether the hail is getting bigger or the winds are getting stronger. There's no way instrumentation or my computer can guess how large of a tree just fell down in your front yard. So it's really essential for us to have spotters, because sometimes it's hard to see exactly what needs to be seen. Some of that is because of our radar. It's one of the main ways that we are able to look at precipitation like rain and snow and thunderstorms coming into our area. But as you know, it has its limits because we do also have a lot of mountains. So what will happen is it's going to spin around and take information as it tilts up and down, but half the time it gets blocked by mountains, by buildings, even by other storms can get in the way, and we'll have a hard time seeing anything. So you can see here, I don't even know it's snowing until it's after the mountains, and that might not be true. So that's why I really need you to fill in the gaps, because there is that issue with what we call beam blockage, and sometimes I can't even see what's going on. But we came here to talk about weather. We are weather nerds. I could talk about weather all day, so let's talk about that for a little bit. Here, typically, we have these 6 types of hazards. These are what we typically see more than anything else. But, you know, you can see anything in really any part of the country. That's the really cool thing about weather, is it can be unexpected at times. Some of these, though, come with hazards. We want to, like I said, keep you safe. So how do we communicate that? And one of the ways is through weather alerts, like I was saying before. We're trying to let you know that there is weather coming in, and it could be potentially life-threatening or dangerous if you don't take certain precautions. So there's 3 types of weather alerts you might receive. An advisory, which is our lower end. It means it may cause a serious inconvenience, especially if you don't take precautions. Things like minor ponding on the road, things like wind gusts that aren't terribly strong, but if you have pool stuff outside or umbrellas, it's probably not the best day to do that. A watch means that the conditions are right for there to be severe weather later and hazards, but it's not happening yet. But we know that there's a good chance based on our weather models, the atmospheric setup. So we're letting you know, like at a watch, that it's probably a good idea to keep an eye to the sky. If you have plans, be prepared to change them, whether it's travel or hiking, that kind of stuff. And then a warning means that that hazard is imminent or occurring, and you should take shelter, do what you need to do to be safe right now. There is no more time. We don't need to call mom and ask her. We don't need to check 10 more websites. We don't need to run outside. The warning means that there's a good chance that you're in some sort of hazardous situation, so you should probably get safe. A lot of times the warning will tell you how to best stay safe, whether it's to go inside or to change travel plans or to expect slick roads. So another way to think of a watch versus a warning is like all the ingredients are there, like a peanut butter and jelly sandwich. You just got to put it together at the right time. It's kind of broad. You have a lot of it. There's a whole loaf of bread and a whole jar of peanut butter and jelly. And then once you get to the sandwich warning, it's all come together, it's perfect, it's small scale, and it's ready to go. It's imminent. Your sandwich time is imminent. And we kept talking about alerts. Now that can mean a lot of things. There's a lot of ways to get alerts nowadays, and they're all great. They're, like I said, we're the official source, so anything that you see is coming from us, whether it's a weather app. Some of you might have seen the wireless emergency alerts coming in on your phone. That's through your cell phone provider. We have a website. If you travel a lot, especially on boat or if you're a camper, NOAA Weather Radio can be a lifesaver. And yes, we are the people who issue the warnings that you see that interrupts your local TV. But that we work with the cable company, and they're happy to get the information to you. My perfect watch or warning to tell you how to be safe and when means nothing if you don't hear it. So it's important to have lots of ways to get weather alerts, because there's always different situations that you might be in. So now we're kind of here to talk about thunderstorms, so we can talk a little bit about how they develop, some of their intricacies. So how do thunderstorms form? We've even had a couple this spring that were a little bit more robust than we usually get. It's been an active spring this year. We've had some already good lightning from some of the storms that we've got. So how does that work, though? How do you get a thunderstorm? Well, you really need 3 ingredients. You have moisture, which is like fuel for a thunderstorm. And you'll kind of know if there's moisture sometimes because you'll feel humid. It's sticky. Your hair might get a little frizzly. That's some of the moisture in the air, especially in summertime thunderstorms. Then you have buoyancy, which is for air to rise. Hot air wants to rise, kind of like a hot air balloon. Another way to think of it might be like a boiling pot of water. And when you turn the water up just a little bit with heat, you get itty bitty little bubbles that are slow to rise. But when you add heat and you add that buoyancy, that instability, the bubbles get bigger, they boil faster, and it becomes almost violent. The atmosphere reacts in the exact same way. If you add that heat and that instability, eventually it's going to boil, and how much you add to that is how violent those bubbles might be. And finally, you need some form of lift. You got to take all that moisture and buoyancy and take it from the surface and push it up higher in the atmosphere to get things like clouds and thunderstorms. So we have a lot of that here. Things, even just from the mountains, can lift things up and over. Low pressure systems, even gust fronts from other thunderstorms can trigger thunderstorms further away. But to get severe thunderstorms, those really hazardous, violent thunderstorms, you need one extra ingredient, and the big thing is wind shear, which is a change of wind speed or direction with altitude. What that's going to do is it's going to rotate your thunderstorm. So if I'm looking at this thunderstorm cloud, and I know that the winds are changing as we go up in the thunderstorm, it has shear. That storm starts spinning almost like a top. And that's when you get your most hazardous and strongest thunderstorms. So monsoon season, that's something that we talk about here a lot. It's when we get most of our thunderstorms. Basically, it's a seasonal wind shift that brings more moisture and thunderstorm activity to the desert Southwest. We're not quite in monsoon season yet, though you would think we were based on how many showers and thunderstorms we've been having lately. But just to let you know, there is hope. We are going to warm up. It is going to dry out a little bit, hopefully by this weekend or the beginning of next week. So just stand by. So what exactly is monsoon season? What does that mean? Well, monsoon itself actually comes from the word season in Arabic because it is a whole season. It's not used to describe one storm specifically. It's more like an atmospheric pattern or setup that's favorable for thunderstorms. Here, our average monsoon season starts mid to late June and will end sometimes mid-September going into October, roughly. The desert Southwest monsoon is different than some of the phenomenon you might have heard in other parts of the country, like the rainforest or in India. Same idea, though, where it's extra moisture. They have a period of just humid and wet and thunderstormy conditions. But this is our Southwest monsoon, which is a little bit different. And as I said, it's basically just an atmospheric setup. During the springtime, you see this here. If you're looking at the upper levels, the high pressure area is locked down in Mexico. So it's over the land, it's far away, and we have lots of dry air coming off the Pacific Ocean because the Pacific Ocean is fairly cool, just not a lot of storms. A lot of that air gets stuck up against these mountains, so we tend to stay dry during the springtime pattern. Then when we get into monsoon season, what happens is the high pressure area moves from Mexico and shifts a little bit to the north and west. And because highs do circulate in clockwise direction, it will take the moisture that's down here in the warm Gulf of California and push it up towards us. So suddenly we have this abundance of moisture. And then from there, it becomes unstable. It's also hot. And then there's always an extra added bonus if you happen to have a hurricane or a tropical system down in the southern Pacific. And that just brings, that's usually when we have our most intense thunderstorms and the most widespread flooding, because tropical systems always have a lot of moisture associated with them. Here you can see a map of lightning frequency across the whole United States. And while it does vary, you can see that every location does get thunderstorms because every thunderstorm is going to have lightning in it. This is specifically cloud to ground, and there are different kinds. So this is just detecting what actually reaches the ground. But that's why it's important to know weather hazards, because if you travel, you might be encountering something you're not usually see in your location, but you can get thunderstorms really anywhere. And with those thunderstorms and with monsoon season typically come numerous hazards, and that's really what we want to know about, because we're trying to inform people about what's going on in their backyards and keep them safe. So we're going to talk a little bit through this section about the hazards you might see in some of the thunderstorms that come through your area. As I said, almost all thunderstorms have lightning, and that can be a widespread issue that people sometimes don't even expect. You think of thunderstorms, you think of tornadoes and winds and hail and heavy rain, but lightning can be its own hazard. There are two types of lightning that you can get out of a thunderstorm. Like I said, cloud to ground lightning, where it's actually connecting with the ground and striking something, or just cloud to cloud, which is a little less dangerous, but still an issue, and still can be a hazard. And you can see from this video why it's important to know that no area is safe outside during a thunderstorm. Lightning can actually strike up to 10 miles ahead of a thunderstorm. So you don't even have to be underneath the thunderstorm to have lightning strike you. So this video is kind of cool because the lightning strikes this plane and you have all these workers who run away. But what you might miss is, so we'll let it go one more time, is while the lightning, watch here, because the lightning strikes the back of the plane, but then it comes through and it hits this manhole cover. That's a steel manhole cover that is flung all the way over here due to the power of the lightning from the back of the plane. So lightning can be really dangerous. It can also travel through things. So it's really never safe to be outside during a thunderstorm. So in general, seek shelter if you hear thunder. We like to say if thunder roars, go indoors, because if you can hear thunder, you're close enough to be hit by lightning. And like you saw there is no safe place outside. So try to get to a sturdy building, somewhere much safer. Sometimes though, like if you're camping, you might not have that option to get to an actual building, in which case maybe your vehicle with the windows rolled up might be your safest alternative to a solid structure that might not be available. The biggest thing is you don't want to be outside, and you especially don't want to be under tall things like trees or power lines, because lightning is going to be attracted to the tallest object. So you want to be at the lowest point. If you have to lay down on the ground, that might be sometimes your easiest solution. And plus, like you saw with the plane, lightning can travel through things. So if it hits the tree, it might continue and spread out over the ground. So it's important to know ahead of time if there is that risk before you go outside for lightning, and be prepared to change your plans. So hail is another big thunderstorm issue that we have. Not as much here in the desert Southwest. It's kind of hot, so we don't get a ton of hail, but it does happen. This was down in California, and that's 3-inch diameter hail. I mean, that's going to do some damage. That's going to hurt windshields. It's going to crack them. If you're outside and you get hit with that, it's going to be hazardous. Windows can break with that. So hail can be a significant hazard as well. So the way hail forms is typically what will happen is you have that buoyancy that I talked about before. You have strong updrafts, you have boiling air, and it's rising and it's picking up these big rain droplets closer to the ground, and it's lofting them up higher into the frozen part of the thunderstorm. So when it does that, eventually the water droplets start to freeze. And this cycle will continue. They'll keep falling slightly, and then the updraft continues bringing it back up. It will continue getting bigger until finally it's so big that the hail will fall through the buoyancy, the updraft, and that's when you get hail here at the surface. The bigger the updraft, the more stronger the thunderstorm, the bigger the hail you typically see. And now this is one of those situations why it's important that I have spotters to talk to who are trained, because under here it's all above freezing, so it's easy for hail to melt. And here in the desert Southwest, sometimes it can be really hot underneath this frozen area, and even though the hail is really big up here, by the time it reaches the ground, it's barely anything. So, but all my radar might see is this part up here. So it's important that you give us a call and let us know exactly what you're seeing so that we can calibrate and kind of move forward from there. It's important, again, not to be outside during thunderstorms, because even if it's hail, you don't want to be this guy. I can promise you he's going to tell you be indoors during a thunderstorm, because this probably hurts. This is, up to ping pong size, golf ball size hail. So Probably not pleasant. It probably was not the best way to end his lawn mowing day. So one of the more frequent things that we see from thunderstorms here are microbursts. We get these every year. They can cause a lot of damage, actually. This is actually a picture from the one just last year in Henderson that ended up doing damage to the Henderson Pavilion that they had to rebuild because the winds were so strong. So the way a microburst forms is we'll have a thunderstorm, and eventually you'll have dry air entering from the sides into the middle of the storm. And when you add dry air, it starts to evaporate some of the cloud. And what that does is it cools the air. You have cooler air aloft. And when you have cool air aloft, cool air wants to sink. So what it will do is it will quickly rush down to the ground and then spread out over the ground because it's just so warm. You can actually see that in this picture where this is definitely the microburst. And then you can see the winds even kicking up outside of it. And winds in a microburst can be dangerous. We've had winds up to 100 miles per hour with some of our microbursts that have happened across our area. And that's even stronger than a weak tornado. So a lot of times you think, oh, thunderstorms go along with tornadoes, and that's the most dangerous thing you can experience. But honestly, you know, straight line winds, microburst winds, they can be just as, if not more, dangerous. So, you know, and they can also be very beautiful. This is a video taken from Black Mountain of that same storm that caused damage down in Green Valley and Henderson, and you can see exactly what I was just talking about, where we you had just a burst of air rush to the ground. That's that cooler air, and when it hit, we had 60, 70, maybe even upwards to 80 mile per hour winds with just that isolated area. It can do a lot of damage. But the way, no matter what you say about microburst, straight line winds, even tornado, what it really is damaging winds. And that can cause, like I said, a lot of issues over a widespread area, things like downed trees, structural damage, things blowing away like gates, power lines down. It took a while after that storm to bring power back to parts of Henderson. So damaging winds can be a big issue. And again, you know, you have to stay safe. You don't want to be outside during a thunderstorm because the winds can also be an issue. If there's things blowing around, it's not going to be good. So you want to go inside a building, and when you're in that building, you want to stay away from windows with the stronger winds. You don't know if the winds are going to blow out that window. You don't know if a tree branch is going to come through that window. So you don't, putting your face up against the window to stare at the thunderstorm probably isn't the best idea in that kind of situation. If you are in a vehicle and you encounter strong winds, a microburst, it's important to slow down and keep both hands on the wheel. It's going to be hard to control the car, so pull over if you can in a safe place. The side of the road might not be the best place, but after the winds go through, if there is damage, you're going to want to avoid things like power lines and debris because that can be dangerous to interact with. And it's especially important to be aware of the wind potential if you are boating or camping, because winds can change suddenly, way ahead of any thunderstorm that might even be overhead. So especially, we always tell people, if possible, to bring your NOAA weather radio, and we're cautious when we're putting out our warnings to understand that there might be people out on boats or out camping or hiking, and they might not have anywhere to go. Because like I said, no place outside is safe during a thunderstorm. This here shows some pieces of a fence that were impaled into a tree because of straight line winds. This was not a tornado. So if you were outside and that was blowing around, it would be very dangerous. So again, just emphasizing, inside is your safest place. Death storms are always an issue here in the desert Southwest. You know, we see here this in Death Valley. We usually get this a couple times a year, big dust storms coming through. Exactly how they form, first you have to have very fine soils, easy to pick up and loft. When they do get sort of lofted, strong winds pick them up, continue to carry them, and eventually they turn into big walls of dust, just continuing to build, and can move over really long distances. They're even worse during a drought because you don't have any of that nice vegetation to hold the dirt down. Everything's really dry. So it's really easy to get dust storms when there's a drought. And we get this, like I said, locally here. Here you see Dolan Springs. Las Vegas, we had a couple last year. Here's a nice picture coming into the actual Las Vegas area. Kingman is another area where we get a lot of our dust storms coming up from southern Mojave Valley. Here's another place out in Mojave County on Pierce Ferry Road, kind of near Kingman, going up towards like Laughlin in that area, Boulder City. And you can see in this series of photos that the visibility reduces down to almost nothing in just a few minutes. This was not taken over a very long time. This wall of dust came in and it was hard to see, and we were able to capture it on some of our webcams. It gets dangerously low. And so that's the main thing with dust storms, is you do want to try to be safe. It really impacts travel because it can cause sudden changing conditions and visibility. The main thing, and Arizona DOT will help me discuss this, but if you drive into it, it's really hard to see what's in front of you. And one of the biggest things that we recommend to people is to pull over and to turn off your lights. Keep your seatbelt on, have a brake set, and don't put your foot on the brake, because those are going to turn off a lot of your lights. And what we're trying to do is not attract other people who can't see anything as well to your car, kind of like where there's nothing else you can see. So that's the main thing that we get from dust storms, is you don't want to be stuck out on the road, because that can cause a dangerous situation. And finally, we're going to talk about flash floods. This is one of our main issues we have here in the desert Southwest, outside of the dust storms and everything, is very rapid flash flooding. Things can change in an instant here with not a whole lot of water. It is our #2 weather fatality that we have across the entire United States, not even here in the desert. So it's an important one to talk about. And by the way, the #1 weather-related fatality is heat. So we got both of that going on here in the desert Southwest. So what is a flash flood exactly? Basically, it's a sudden, fast-moving flood. It's water rushing, and it can travel long distances from the parent storm. You do not need to be raining at your location in order to expect a flash flood. This is especially important when you're hiking or traveling in the mountains, because all that water is going to flow somewhere. So it's important to know exactly what's happening in just your general vicinity. They're common, like I said, across the desert Southwest, and they typically follow drainages, low water crossings, washes, and they can happen very fast. That's the biggest issue with flash floods, is that you can go from nothing to rushing water, and if you're sitting in one of those drainages or you're camping in a wash, it can be really dangerous. The big thing to do here is you'd never want to drive into flooded waters, and that's unfortunately one of the main ways that we record flash flood fatalities, was from people who drive straight into flooded roadways. And you don't want to do that, because you don't know how deep that water is, you don't know how fast that water is flowing, and as you can see here, you don't know what's in that water. So it's a good example why you don't want to just drive into water, because you don't know exactly the whole story. So I'm going to preface this video with everybody was okay, and they all got out and survived. But with this video, recorded way back when, and that's why the quality is oh so awesome, this guy actually had a moment to decide not to drive through the flooded roadway, and we can tell it's flooded and that it's moving. But he decided either way that it was a good idea to try to drive across the flooded area. Okay, and you just don't know. It doesn't take a lot to wash away, especially a small car like this. So it doesn't even look like it's a whole lot of water. You know, it's not terribly deep, but it's moving so fast. that easily picks up the car and washes him downstream. Eventually the car actually flips over. He was rescued. Everyone was okay, but that's something else you have to consider is if you get stuck in flash flood situation, it puts others in risk. We are prepared here in the desert Southwest for swift water rescues, but it can be very dangerous. So yes, he was okay. And even closer to home, I mean, this was from Joshua Tree down in California, and it's not a whole lot of water at first. You think it's going to be okay, but you can see coming downstream how quickly that can change. And if you were standing there, that's a lot of mud, that's a lot of sticks, that's a lot of rocks, and it's a lot of power coming from one wall of water. So that's, you know, if you're camping, sitting up in the washes, you know, canyons can be really dangerous like this too. So it's important to check the weather before you go and have a way to receive weather alerts so that you know if you need to get out of someplace quickly. And this was the famous Moapa flood. Again, I'm going to preface it with everybody was okay and got out safe. This flooding, we still had people try to drive across it. This was actually I-15, and it took out parts of I-15. There was just so much water. And this car was unfortunate that it did get stuck and eventually does go over. And we even had people trying to get into the car and save it. Everybody was luckily okay, but those are just not good decisions to make. It's putting a lot of people at risk, including yourself, and that's the one thing we don't want. So if you hear there's a flash flood warning, or if you see a closed roadway, it's best to just listen to the roadway, don't chance it, because you never know what you're going to encounter. Because it only takes 2 feet of flowing water, which is what we kind of saw with that first video, to wash away most cars. It doesn't take a whole lot, and only 6 inches to wash away people if you're standing in flooded areas. And so we, like I said, we try to tell people to avoid canyons and washes when there are storms in the area. One of those things, you know, if you hear thunder, you might be close enough to encounter flash flooding. And again, never drive through flooded roadways or washes. If you see a closed road sign, if you see there's a significant amount of water in the road, turn around, don't drown, don't chance it. It's just not worth it. So changing a little bit, we have some other kinds of weather kind of cloud formations that we sometimes see. They're not quite as prevalent, but this one here we actually see often, and they're so hard to communicate. Gust fronts are basically the leading edge of rain. So you'll have a thunderstorm, it cools the air, and it rushes out away from it. And sometimes it rushes so quickly that it can move and have winds with it that are sometimes 50 to 60 miles per hour. And the main thing about this is it's ahead of the actual thunderstorm. It does not need to be raining or thundering overhead or even nearby to get this sudden burst of strong winds. We get this a lot here in Las Vegas Valley. It'll be sunny, not a whole lot of issues, and suddenly the winds pick up to 60 miles per hour. And it's hard to communicate that to people and to stay safe with that because they look outside and they say, oh, it's beautiful out. I don't know what you're talking about. The other big thing with this is if it's traveling a long distance, it can pick up dust. So we can have that dust storm situation again. Here we see this out back basically from our office. And the big thing here is you can see the gust front is actually these lower clouds and they're propagating forward, but the rain is all the way back here. So it's windy here. You can kind of tell because there is that lowering of the clouds, but back here is where it's raining. So that wind hazard is ahead of the actual storm. But it can be a big, much larger scale. This is from last year in Phoenix, and there was a gust front. You can see it up here, and it created a haboob, or a very large-scale dust storm that engulfed the city. You can see the whole wall of dust coming in here. And again, this was not from, it wasn't a windy day. It wasn't a thunderstorm overhead. It was just winds that got out ahead of a thunderstorm with a gust front. And these can catch people off guard if they're not prepared. Not to be confused with the gust front is wall clouds. The difference between this is they're typically in a different part of the cloud. of the thunderstorm itself. So you're always going to see this with the thunderstorm. It can be rotating, and it's lowering of that cloud base. Sometimes it's hard to tell if it's rotating, but if it is, it's the precursor to sometimes a tornado. Not something, like I said, we typically see here a whole lot, but we do have a couple of cases where we've had rotating wall clouds here in the Southwest. You see this a lot, especially in places like Texas, Tornado Alley. This is one of the first things they'll look for before they start watching for tornadoes. But we do get it here. This is out there, Lake Havasu City, where we did have this wall cloud structure. This was slowly rotating. And what's important to know about this is if it is rotating, especially, it can be really severe storms. This is a good indicator that you have a strong, severe thunderstorm, and it's going to have all those thunderstorm hazards with it, and they could be significant. So that's why we like knowing about them, because it's kind of a way to say that this storm is very strong. It may need extra attention. Funnel clouds come out, and tornadoes come out of sometimes wall clouds. And so you're going to ask, what is a funnel cloud? But how is it different than a tornado? A funnel cloud is a rotating funnel shape coming down from the cloud itself, but it is not in contact with the ground. So the big things here is it's coming down from the cloud, it's rotating, and it has not touched the ground. So it's still a funnel cloud. Funnel clouds can become tornadoes eventually as they continue to lower, and if they do reach the ground, but you're always going to get a funnel cloud before you see a tornado. So, but they do sometimes become tornadoes. Not the biggest issue here, but we do have them. Here's one down in southern Clark County, 2014. We did go out and look at this, so it's hard to tell here, but there is some debris being kicked up in this picture. And we also went out and looked at this area and found some rocks and debris thrown around. So this was a rotating column of air in contact with the ground. So it was classified as a tornado. Like I said, though, it's not the most prevalent thing here in our area, but they do happen. We do have some reports on this tornado map of documented tornadoes, but you can see it's not quite as prevalent as what you see out here. But it is still important to know, because no matter where you are, there is the potential for severe weather, and with that brings the potential for tornadoes. And even recently, out in Pahrump, there was a tornado. We received information from the local TV station. They sent us this video, and the big thing here is, as you can see, it is kicking up debris from the ground, so it is in contact with the ground, and excuse me, it is attached to the cloud. So they're really hard to tell. Here in Nevada, we usually average about 2 per year at the most. July has the highest instances of documented tornadoes going back to 1950. The problem with our tornadoes here is because we don't get those beautiful supercells or really strong thunderstorms like you see in Tornado Alley. They're quick, they're weak, and they're difficult to detect on radar. That doesn't mean that they do any damage or cause any kind of debris. This one here, luckily near Pahrump, was in the middle of a field for the most part, so it didn't do too much damage, so that was pretty good. And it was interesting because there's never been a documented tornado over an EF1, which is a weaker side tornado. It goes from EF0 to EF5. EF5 are those really big ones that you see down in the Central Plains. And EF1 is going to have winds 86 to 100 miles per hour. But like I said, more often than not, we're going to get that out of our straight line wind or microburst situations than we're ever going to get out of tornado. But it's going to cause just as much damage. So we just talked about a lot of weather. Now we're going to get into some review. We're going to talk about a couple questions, and we'll also tell you how to report information back to us, because we are scientists here. We do want some accuracy, so we're going to let you know how we usually report severe weather so that everybody's kind of on the same page. So the question is you see some of the significant weather I just talked about, and who are you going to call? Well, hopefully you're going to call us, maybe after you call your mom and you take a couple pictures. But we want to know. Your reports are essential to us because we use your information in real time. Weather can be difficult and different day to day. So just because something happened yesterday doesn't mean it's going to happen today. It aids in our warning decisions. You know, sometimes we're going to be on the fence. A storm might be causing hazardous weather at the surface, but we're not quite sure. But you call in and say that you have strong winds and quarter-size hail, and now I'm putting out the warning, and everyone down in the rest of the community knows to go inside and be safe. So we use your reports in real time. It helps us let us know how the radar is doing compared to our observations. We can alert events and partners if you call in and tell me that you're getting 60-mile-per-hour winds and Lake Havasu is having a big boat regatta and I see that the winds are going towards them. I'm probably going to call the officials there to let them know that, hey, you have strong winds. It was reported by somebody, and that's the biggest thing too. If I'm putting out warnings and it says somebody has actually seen this and it's happening, it has a lot more weight than I think this is happening based on the radar and what I'm looking at. It also provides for future research. We can use it for studies, for climate. So we use all of this a lot more than you probably think. And the big thing is your report may save lives. By letting us know, we can tell other people, and other people can take action that they might not have done before. So we appreciate your reports, and it's important that you talk to us. So what exactly do you report? Well, the big thing is you can contact us anytime that you see weather impacting your community, because it's probably going to impact others in your community. So we want to let other people know. So we're here 24/7. You can call us. We do have contact information towards the end, and we always are looking for more reports. And the big thing is we want to know as soon as possible, and it's safe. If it's not safe for you to somehow contact us in that exact moment, that's fine. We take late reports. Just let us know when it happened. You know, it was 15 minutes ago. There was hail. I had to take cover, but now it's done. We want you to be safe. It's our mission statement. So if you're not doing that, it's kind of going against what we're just trying to achieve. So if you do see a tornado or a funnel cloud, here's another example from Yucca Valley. And you can see our tornadoes are just so wimpy compared to what you typically see on like the Weather Channel. We want to know where you saw it, what direction it was moving, and was there any damage? And also the big thing, like I said, with tornadoes and funnel clouds is it rotating? And is it touching the ground? Because that's going to, one, tell me it's a tornado or a funnel cloud, and then tell me the difference. There are a lot of scary looking clouds out there, but if it's not rotating, then it's probably not a tornado or a funnel cloud. We want you to report winds, specifically wind damage, and try to be as specific about the damage as you can be. Describe how big the branches were that fell in your yard. Was it one branch? Did lots of branches come down? Is the power out in your community? Did pieces of your fence fly away? All this can tell us that information, you know, and tell us how strong those winds are and how damaging they might be. And we can use that in our warnings. Specifically, we're hoping for winds over 40 miles per hour if you are able to guess or measure the winds. You don't have to have a way to measure the winds in order to be a spotter. We usually estimate based on the kind of damage that you're seeing. So basically, if you start seeing numerous branches coming down, just small branches, you're probably starting to see that 40-mile-per-hour range where we might want some information. But especially when you start seeing like small trees, you know, shingles maybe coming off, your fence might be having issues and blowing away to the neighbor's house, give us a call. That's when we're starting to get into those really damaging winds that might cause issues for other people. If you do encounter hail, we want to know about that. We want to compare it to the most common size. And the biggest thing here is we want the size of the largest stone. So if you have a lot of hail and it's varying sizes, we want the biggest size. You want to measure across the longest part of the hailstone. We saw in the beginning kind of one of those spiky looking hailstones. They're not always nice and round. So you want to take the parts of the spikes and the longest parts. And don't call and tell me that you have marble-sized hail. A lot of us are younger, and marbles vary in size, so it doesn't tell us a whole lot. It's best to try to compare it to common objects, coins, sporting equipment like baseballs or softballs. Here in this picture, we would also want to know if it was a lot of hail. So this isn't really significant hail, it's pretty small. This was up on Mount Charleston last year, and it caused not only issues because it made slick roadways because there was so much hail, but then it melted, and we had issues with some minor flooding. So if you get a lot of hail, like you see here, almost like it's snowing, even if it is tiny hail, we'll still take that report. And as I said, if you have a ruler, you're more than welcome to measure it and let us know that you did measure it. Here with this storm here, we probably go 2.5, almost 3 inches. But I understand not everybody carries a ruler in their back pocket. So comparing it to common objects here, quarter size, dime size, you know, the softball size, ping pong ball size, things that everybody's going to kind of know what size that is. We'll take that too. Here you can kind of see a chart of some of the sizes that we sometimes use: golf ball, ping pong, tennis balls. They're always going to be about the same size. So we want you to report flooding, any kind of flooding specifically. You know, where was the flooding? Be as specific as possible. I'm at the intersection of blank and blank. I'm in the Walmart parking lot and I can't get out because the water is flowing. How deep is the water? Please don't go in it and try to measure, but you can say things like it's up and over the curb, or it's flowing into people's basements. That tells us a little bit more about the actual water depth. You don't have to drive into it like these people are, or actually measure it. The type, and that kind of goes to the 2 videos, whether it's flash flooding or just regular standing flooding. So in the first video here, we have pretty much it's not flowing very fast. It's kind of pooling in this intersection. These people got the right idea. He's trying, but he does go around the corner and his car gets his stalls. But this guy turns around, so that was good. But here we have flowing water. This would be flash flooding. Water is flowing across at a significant rate. So, and then if you do have any impacts, like the road here is closed in both locations, you can tell us, you know, why the road is closed here because of flooding. And again, never drive through flooded roadways so that you don't have to lose your car or unfortunately your life. You can report miscellaneous stuff. We talked about dust storms. We specifically want to know things about like visibility. Can you not see very far? Are you having difficulties driving? How strong the winds are. Same with fog. We do get fog, especially near the winter and especially up on some of the higher terrain like Mount Charleston and the Sierras. So with that same thing, if you can't see how far in front of you, and are you having trouble driving because you can't see. Snow, how deep it might be, if it is causing impacts to the roads. Are the roads slick? Are they closed? Are they snow covered? Are you having visibility issues? If you are going to measure the snow, which I'd like to say doesn't happen here, but unfortunately we just had a snowstorm here in the Las Vegas Valley with up to 8 inches of snow. So if you do happen to have a snow event and you want to measure, make sure you pick a flat surface away from the house. I don't want the snowdrift that's smushed up against your house. Don't measure in the grass because it tends to settle the wrong way in the grass and you're going to get an inflated measurement. So here we have about 8.5, 9 inches of snow on a flat surface. This is a good example of taking a measurement. So just to kind of go over what we just talked about, what to report, that web page that we'll also have at the end has a brochure that you can print out that has all this information. You can also access this information on any of our websites about what exactly it is that we're looking for. And again, your timely reports are essential to the weather warning process. We're using this. So we always appreciate information. I'm never sitting at my desk going, wow, I wish these people would stop telling me good information, like telling me the weather. I don't need more reports. I'm always looking for more information. So when you do call in, you finally see some weather, you want to let us know. There's some important information that you need to tell us. We want to know who you are, specifically that you are a trained spotter. It's important to know that you've gone through this training and you know exactly what you're looking for. What you see, what kind of hazard, when you saw it, because like I said, Maybe you couldn't report right away, or maybe you were driving home from work and now you're home. Where you saw it, and be as specific as possible, and how much damage, was there damage, was it widespread damage? That can kind of tell us a little bit as well about the type of weather that you were seeing. And it's important to assume that we don't assume that we know what's going on in your backyard. Like I said, you saw weather has lots of technological issues. A lot of things can go wrong between the cloud and the ground. I might not know what's happening in your backyard, even if it seems significant. So you're always welcome to call us or contact us in some way. So some examples of some reports that we typically get. Here's one on Facebook. You can follow us on Facebook, and we love weather pictures and reports through Facebook. So here we have a report on Facebook with a picture of a trained weather spotter reporting lots of trees down at the corner of XX and YYY in a city and state, and the power is currently out. So they told me not only was it, if you say a tree is down, that doesn't tell me a whole lot. There's a lot of information there I can work with. I know exactly where it was, and that it obviously isn't localized because the power is out in town. But if you tell me heavy winds outside, it doesn't tell me a whole lot. I don't know what a heavy wind is, first of all. That was not taught to me in my science books. I don't know where you are. I don't know what time it occurred, and I don't know if it's actually impacting anything. So having information about what you're seeing definitely helps. And pictures are just bonus points. Not required, but bonus points. Here we have a almost good report. He told me that he's a trained weather spotter, and he's tweeting at us, so we're able to actually see those in real time as they come in. And here, not so much. He didn't tell me where he is. Yeah, the sky is falling can mean a lot of things. I don't know if that's hail. I don't know if that's dust. I don't know if that's wind. And when you mix it in with a bajillion hashtags, it just doesn't help me. We do have some hashtags that we specifically look for, but this report just didn't give me a whole lot of information. So just to wrap up on how to report, your reports are, again, invaluable. We accept late reports. Even if you go down to your boat a week later and you realize that, let's say you have boat damage, we'll take that as well, because obviously something happened at some point, but you're only just seeing it. Safety first, always and foremost. You can share your reports that you find on social media. If your friends have a picture of a tree down on Twitter, you're welcome to tag us and share that as well, and we might communicate with you or with your friend. And use your judgment when you see things on social media or online. Not everything you see is true. This picture here goes around almost every hurricane that comes through at some point. It's not real. I've seen it associated with Michael. I've seen it associated with Hurricane Harvey. I've seen it with Katrina. It's not real, so you kind of have to sometimes ask yourself, like, does this make sense? Google image search is your friend. So if you're ever in doubt, you might want to take a look. Because unfortunately, there's a lot of bad weather information and made up weather information out there. Okay, so now it's time for a review. We're going to go through some questions. I'm going to give you the answers, and we'll be able to see how much exactly you learned today. So here you are, you're driving, and there's this road, and you see water. So what would you do? You could drive slowly through the water. I mean, it might not be that deep. You can gun it and cross your fingers. If you are fast enough, you never know. Turn around, don't drown, or stop, drop, and roll. We'll give you a second to consider your options. I'm going to go ahead and say it's not D, unless maybe the water is on fire. Obviously, like we've been saying, turn around, don't drown. It's never worth driving through flooded roadways. There's a lot that you might not know here about this water. So it's worth just waiting. So here we have this beautiful weather picture. So what is it that we're looking at? Is it a tornado, a gust front or dust storm, a flash flood, or a danger cloud? I will accept D as an answer. But we know let's think about each one of these. So it's not a tornado, we don't think. It's hard to tell from this photo because the big thing about a tornado is it rotating and is it touching the ground? And you do have some debris being kicked up, but nothing's really coming out of the cloud. It doesn't really seem like it's rotating. There's no funnel. So we're going to go ahead and think it's not a tornado. It's not a flash flood because it's not raining and there's no water. Even if it wasn't raining, it could be a flash flood, but I don't see any water flowing. So we're going to go ahead and say this is a gust front or dust storm. This is the beginning of that gust front. Remember the lowering of the clouds? And here it's blatantly windy because it's kicking up that dust. So you have that windy gust front, and then you have what are probably the beginnings of a pretty widespread dust storm. So here we have some hail and a ruler. So what hail size do we report? The smallest stone, all of the stone sizes, the largest stone, or you could make something up. I don't recommend D though because we are scientists and we're trying to be accurate and we appreciate accurate reports. So if you remember correctly, we want the largest stone because it's going to tell us how strong that storm is. At some point, it was strong enough to loft this stone and make it this big. But you can see here how we have a lot of stone sizes. And you can tell us, like, it ranged from pea-size hail to up to 1-inch hail. But what's most important to us is that you did have these larger stones in with all the other stones. So what time of year is monsoon season? You see these beautiful thunderstorms. It might be monsoon season. November through February, March through May, June through September, or October through December. So as we discussed earlier about weather and thunderstorms, it's when we typically get most of our thunderstorms is in monsoon season. And that usually is more towards the summertime when that high over Mexico shifts to the south, to the north and west, and we get a little bit moisture being pushed up into our area. So that would be more June through September, that summertime time frame. So here we have this picture, and the question is what is this? Is it a tornado, a dust devil, a funnel cloud, or a gust front? It's hard to tell from this photo. It does kind of look like it's plainly coming from the cloud. Dust devils are rotating columns of air, but they originate at the surface, so you'll see them kind of coming up. And it's not a gust front because it's not widespread. So it's either a tornado or a funnel cloud. Based on the picture, we're going to say it's a funnel cloud. The big giveaway here is there's no debris being kicked up near the surface. You don't always have to see the whole tornado connecting to the ground. The dead giveaway is whether or not you're getting debris and dust and dirt being kicked up at the surface. So which is the better report? Report A, where stormy weather, reports quarter-size hail falling at Flamingo, starting about a minute and still falling. B, Shady Sally's telling me it's raining. And then Geeky Gary says, wow, I just saw this really very real picture just now, definitely real, of this rainbow, tornado rainbow. So we're going to go ahead and use our science here. This doesn't give me enough information. It's raining. Well, that's good. Is it raining heavy? Is it flooding? Where is it raining? So it's not B. And C is a really pretty picture, but it's one of those situations where you have to consider, if this looks fake, it's probably fake. So it's probably not an actual weather report. So the answer is A. You have this person reporting in the size of the hail, exactly where the hail was falling, and that it started about a minute ago and was still ongoing. So this would be the best report if you're reporting on social media, especially without any kind of picture. So hopefully you did pretty well in the review, and we've learned a few things. You know how to talk to us. You're always welcome also to ask questions. You can call us with a report, and we're probably going to ask you more questions anyway. So don't hesitate to contact us. We have lots of ways to contact us, and like I said, we are here 24/7, 365 days a year. Weather happens at all hours on all days, so we're here all the time. One of the best ways to contact us is on the spotter phone number. All this information is at the end again if we go through it too quickly, and you're always welcome to ask. So that 1-800 number gets directly into the office on our specific spotter hotline. So we know that the person calling in has taken this training and has that number because they took that training and is a spotter. So again, phone call is always great because then we get to ask more questions. It's a little bit more interactive. Sometimes if you give us your information, we might call you. If we see a storm going over and we want to know, hey, did that hail? And we see that you are willing for us to call you, we might call you and ask if anything happened when that storm went over. We are on Twitter, so you can tag us. We're at NWS Vegas is our actual account. We also monitor these hashtags. If you want to use the hashtag associated with your state that you're in, so depending on which one the actual weather is happening, or you can direct message us. We do have an inbox that we respond to pretty quickly. You can use our mobile account as well to get directly. So if you have a Twitter, you can get directly to mobile.weather.gov, go to Las Vegas, and tweet a weather report. And it will give your exact lat long in that. So that's a little bit more information. And it will tag it with that hashtag weather report that we also search for. So that's another way if you're on your phone and your mobile. Going to this website is going to give you all this information about your area, and that's one way to contact us is with this one right here. This is what it looks like if you do click it and bring it up. Like I said, you do have to have a Twitter report, but it does put in that specific information and it tags us. We are on Facebook. This is probably a good way to share a lot of pictures too. During weather events, we're probably on Twitter more than we're on Facebook, but we monitor both. We'll also post a lot of great weather information, weather updates, radar updates, climate stats on our social media. So if you're not following us on social media, I highly recommend it because you'll get a lot of cool weather information. So you can come here, post to our site about what weather you're seeing. And we do happen to have an email if you prefer to email, and send us information that way. So lots of ways to contact us. Whatever works best for you. We don't have a preference. Sometimes calling's better, but whatever works for you really is the important thing.